Hi, I'm Kylie Whitehead. Welcome to the PolyAI podcast. I'm joined today by Pavel Budzianowski. Hi, Pavel.
Hey, how's it going on?
Pavel is the head of machine learning at PolyAI, and he also teaches an NLP course for machine learning master's programs at Warsaw University and Jagiellonian University. Pavel has a bachelor degree in maths and earned his PhD at the Dialogue Systems Group at Cambridge University, working on conversational agents. He's published 40 papers on dialogue systems and his work's been cited over 2,000 times. So who better to cover our topic today, which is voice recognition? And great voice or speech recognition is absolutely crucial to creating a usable voice assistant, but we've all had a bad experience to the point where it's kind of a bit of a meme now. And I'm thinking of a scene, I don't know if you've seen the Jordan Peele film, Us. And somebody's shouting, "Alexa, call the police," and it starts playing the NWA song and just carnage ensues. So Pavel, I'd love to understand a little bit more about how we got to this point. So tell me, I mean, engineers have been working on speech recognition for a really long time, right?
Yep. Yep. It's been a long journey. It's been over, I would say, 70 years since we, as a computer scientist, started looking into this problem. I mean, obvious applications all over the world in every appliance, right? We would like to talk to the appliance rather than type it, whatever comments we would need to do, right? But funny enough, one of the biggest starting point for speech recognition was actually things that were happening after the Second World War and the Cold War between USA and Soviet Union. And where scientists basically were tasked to figure it out how to properly spy on other on phone calls or just emails, right? That's where speech recognition and machine translation were born, and that's where we start basically trying to figure it out how to recognize speech, in multiple languages. And since 50s, there's been a variety of different approaches. And over the years, you see all of this, all of them in the generation of appliances, including all these funny issues that we had up until, I would say, 2017, 2018. I would say I would start from one of the most memorable part where IBM released Showbox. It's been already 70 years, which is it's crazy how early actually that type of appliance existed there, where essentially they created a mini computer that could recognize numbers from 0 to 9. It actually worked quite okay. And to a lot of people were like first signs of something out of this world. A lot of people were calling it fake. They were basically checking whether there's a human being behind the stage, right, who was recognizing this. But it actually, it was working. There was really little AI, but it was a lot of signal processing, a lot of signal, recognition, because the way we say 0 versus 9 is much different, right? So the wavelength is much different. And thanks to that, they could understand what's going on there. But as you can imagine, communicating with machines through numbers and simple comments is not ideal UX that you can imagine, right? Especially if you're calling the police, or like you need really a big help because your internet doesn't work right in your room. That's why, right, we moved to much more complex models, and that's where we could call and start to say that AI started coming in the disguise of the statistical models. And here is like a really sophisticated name that pops on the stage, which is called hidden Markov models. Not going into much of the details, because there is a lot of maths that unfortunately is not really needed anymore, because we have neural networks that we're going to get to pretty soon, right? Hidden Markov models were first statistical models that were very good at explicitly modeling parts of speech that we say, which we call phonemes, or like, small units of speech that that put together compose words and the whole sentences. And essentially, since 60s, 70s, all of these models that were behind speech recognition systems were using these hidden Markov models to properly model these phonemes. There's around 40, 50, 60, depending how you're going to define them. And essentially, the model was trained to properly divide the wavelength that was getting into these phones. Um, and these models were, again, a revolutionary because you can go above the just digits and simple comments into, in theory, full sentences. And in 70s and 80s, there was a lot of progress in terms of recognition, and that led to famous first system, the first commercial system, Dragon, that was released as a product, as a standalone product for speech recognition use cases, that basically paved the way to what we observe today.
So the first version of Dragon, I was reading about this earlier. The
Yeah,
first version of Dragon couldn't tell couldn't tell when you ended one word and started the
yeah,
next word.
yeah,
And I saw that it was 1997 until
yeah.
we had like continuous speech recognition. So that's 30 years ago. Why is speech recognition still so bad?
Yeah. Yeah. So since the release of the Dragon Natural Speaking, I think that's the one you were talking about
Yes.
in 1997, all of these systems up until 2017 were based on these hidden Markov models. And as with all of the AI models that were released before neural network deep learning revolution that happened in the last 5 years, and with all of the outcomes that you see today, like ChatGPT, all of these models learn from the data, which is a crucial aspect of AI, right? Just like humans, these systems learn from the data, but they had this visible invisible ceiling up until like they were learning quite okay, and then later on, once you are adding more and more data, the system didn't really improve because it had this ceiling of capabilities and inherently inside of these models. So these models were released since 1997, a lot of work was put into like tweaking them up, making them better. We sort of got to the point where continuous speech, even with British accents, could be recognized quite easily in favorable condition, right? Yeah, imagine no rain, no much of a noise, no other speakers in the room, just you with your good clear audio. That's where things were okay, actually. And these systems were deployed in production and they work well. Well, the moment you put your voice through the phone, very low resolution, there is gonna be a lot of people talking around you. Systems completely broke, and we couldn't really get past through that because even though we were throwing more and more data, right? We have internet era. People are sending mails, talking through Skype, you name it, right? We weren't improving as demand was improving. And that has radically changed around 2012, actually, a little bit earlier than 2017, where we start to see one of the first magical revolution in AI that is somehow overlooked these days because of Chat GPT and all of the repercussion of it. But actually, the first moment where everyone realized that there's something being coming in through deep learning and neural networks were improvements that we did in speech recognition through applying deep learning rather than hidden Markov models. And that's where the defining moment that basically changed the whole scene.
That's interesting. Did you know that? So I guess a few years after
Yeah,
that came out, AOL Movie Phone introduced speech recognition. So you used to have to phone up and it would say like press, if you know the movie you'd like to see, press one.
yeah,
Um, and then there was that episode of Seinfeld where Kramer's like line gets crossed with movie phone, or he gets a number that is similar to movie phones, and he ends up like obviously can't understand the button key press. So he says, "Why don't you just tell me what film you want to see?" Um, and that was actually the inspiration behind movie phone using speech recognition. It's kind of
Oh wow.
how Cosmo Kramer invented speech recognition.
These small
Yeah,
things, right? Yeah.
yeah, really, really interesting. Um, so I think you kind of touched on this earlier around, we get to this point in 2012 where deep learning has progressed. Um, and the 2010s were a really big time for this, right? Like a lot
Yep.
changed between 2010 and
Yep.
2020.
Yep. Quite a bit. Where the most important thing is that since people started calling more and more systems, they were more inclined to talk to variety of AIs. I mean, we had Siri, right, since 2000, I think 13, 14, if I'm correct, maybe even earlier. People they started got to accustomed to that, right? These old IVR systems were kind of a passe already back then, even though they still exist these days. I don't know why, but people should be using PolyAI already everywhere. But essentially, we started getting a lot of data. And as I said, there is a huge difference between hidden Markov models and deep learning and neural networks. Because the more data that we have, the better deep learning based systems will be essentially perform. And in 2010, 2012, were first research popped out showing that with more and more data, we actually finally passed the bar of the performance of old type of models with these new models. That's when the history basically has changed, because that was a sign that we found a way to train these big neural networks. We're talking about millions of parameters, right? Up until now, we were getting to the point where we have more and more parameters, to the point that we have as many parameters in some networks as we might have neurons in the brain, which is crazy numbers. And still, these systems were able to train, and with more data, they were performing even better. So, what you would observe if you would be following the research papers that were popping up basically every month, it was like crazy race between different universities and also research labs, is that every couple of months there was a new basically record in terms of how good the systems are. And that led to the, I would say, 2015, 16, 17, when even us back in the uni times, the original founders of PolyAI, we could train systems like that, with deep learning behind these systems that were completely destroying the previous models that required 200 people working on them, a massive amount of annotators tweaking them up with just one computer and a couple of gigabytes of transcribed data. And that basically led to the situation that you have these, old players like Dragon. You have Siri that, not going to understand you well. Alexa came out, right? And that's where like, that was like this moment, like, okay, let's change the situation, at least from our perspective.
Cool. And loads has changed since then, right? Like 2017. I know that you've been at PolyAI since the beginning. I wasn't too far behind you.
Yeah.
But I can see a difference in what we've been able to achieve since 2017. So what has changed since then to allow, companies
Yeah.
like us to really hit this quality in terms of speech
Yeah.
recognition?
Yeah. Absolutely. Um, One of the things that became a standard that it wasn't the case before 2017, that everybody was kind of building their own models, their own deep learning models. Um, there were a lot of different ideas how to create these systems in terms of the structure of neural networks. You can think of like different way of wiring neurons in your brain. But since 2016 to 2017, there became like a standard way of building these neural networks. And it was just a matter of right, correct data to improve these systems. And at PolyAI, we initially were also doing quite a lot of research how to build these type of systems. We were competing with different other providers, But since we are getting more and more clients at different domains and insights about them, we were able to find a way to use, let's say, off the shelf pre-trained models that are available to basically every research group or every company, and adapt to exactly the way people talk. We're going back to this funny anecdote that you mentioned before. It's all about the context. It's all about, right, a situation where people call on the phone, which is a completely different data type that, for example, you have when you're having a podcast where we are explicitly were made sure, right, that we're not going to have noisy room or people around us, so that people who are watching us going to have the best experience, right? So here, we cannot, of course, request that from the consumers, because they might call, hotel, restaurants. I mean, we have so many domains these days that I'm getting lost actually in terms of the use cases. But essentially, thanks to the access to this data, we knew what type of data we should throw at our model to make the model, be receptive to that, as that ecosystem that typically is involved on the phone calls. And that's became kind of a game changer when it comes to understanding, what people really talk about through the phone rather than through the perfect, you know, um, perfect in the perfect environment when they, for example, do the podcast or just talk on YouTube.
Yeah. I love that, as you said, about us both finding quiet places to record this podcast. Like a bus went out, you passed outside your window, I think, and it was like,
Yeah,
you could hear the background noise. It was like
yeah,
perfect timing. Um, I mean, the phone is such a strange, like even right now, we're looking at each other, you can kind of see my mouth move, you can see my
yeah,
facial expressions, you can, even if you don't catch 100% of what I'm saying, you kind of fill in the gaps, right?
yes, that's
Um, and you don't have that luxury with the phone. Like there's no visual. It is just the words that are being said, no body language, nothing. Can, um, can speech recognition catch some of those cues in like how
yeah,
people sound or,
yeah. That's an amazing question. That's one of the actually research questions that I'm still dreaming about, because we are still not there yet. So let me answer with what we are doing this right now and what's going to be the ultimate goal of these models. So at PolyAI, we typically work with multiple ASR systems at once. In some cases, we are looking at n-best lists. So our models are able to provide multiple hypotheses of what you say. As you said, when we're talking on the phone, right? I don't see your emotions, though. I don't see your lips. I don't know exactly what might have been said, because there's also a lot of errors over the line. So I might do the guessing, right? If I'm going to say check in when I'm calling the hotel, it's a little bit higher probability that you say check in instead of chicken. So that type of stuff actually happens, and you might see the best answer system that's going to go for chicken without check in, because it just doesn't have that context, right? And that's how we were, by combining a lot of hypotheses, we were able to extract the right one to be used in the systems. But thinking about what's going to happen in the future, when we're going to have more and more AI systems combined, the systems that understand pictures, the systems that understand audio, the systems that understand text, you can imagine building a answer system where you kind of tell the system what type of dialogues or data the system should expect to get into, right? So if you think about like understanding the conversation over the phone line when people are calling it a restaurant, um, and the model will be able to create conceptually what is the restaurant, what type of sentences might be spoken in that scenario. You can imagine that all of these chicken hypotheses will go away, because like if I explain it right, you're a receptionist at the hotel, right? It's almost zero that you start talking about some anecdotes about chicken instead of actually asking about the chicken. I mean, somebody could ask some questions around that, but the probability is low. So that's basically the future that we're going for. It's clear that that's going to happen. There's already some research work, but it's we're essentially getting there. And once that will happen, my predictions is that all of the last 1% errors that we're observing in production will go.
There are instances, right, where, I mean, this is not quite the best example, but there are instances where perhaps somebody has an accent and they are saying chicken, like,
Yeah.
but they mean chicken, but it
Yes.
sounds exactly like chicken.
Yeah.
I think accents provide quite a problem, like quite a hurdle for speech recognition, right? Because, if I'm talking to somebody, I know what accent to expect,
Yeah.
I think it's easier to understand. Whereas if you speak to somebody with an accent that you're not really familiar with, it can be much more difficult to understand.
That's absolutely right. And that's why I mentioned before. If we know, for example, at PolyAI that in one of our deployments there might be calling people from a lot of different geographical places with different accents, we typically we are using multiple ASR systems so that we can combine a lot of hypotheses together, and typically the best solution.
Amazing. Thank you so much for talking me through all of that, Pavel.
Sure.
Do you want to record another episode soon where we talk about voice generation?
Absolutely. Let's go on the other way around and let's talk about voice. Yeah.
Very cool. Okay, so keep your eyes and ears peeled for that. You can listen to previous episodes of the PolyAI podcast on our YouTube channel at PolyAI Voice. And you can find us on LinkedIn for all the latest news and updates. So once again, big thank you to our special guest, Pavel.
Thank you. Pleasure.
And until next time, take care.